Okay, we're on lesson 3.5, Proving Lines Parallel. This is the last lesson in our chapter. There is another section in the book, but we're stopping here at 3.5. These lines in this optical illusion do not appear as though they are going to be parallel, but if you were to lay down a piece of paper and trace, you'd find out that these lines are actually parallel, whether they look like it or not. What we're going to do today is kind of very similar to what you already learned. It's actually the converse statement. So previously we said if lines are parallel, then corresponding angles are congruent. Okay, now we're going to say if corresponding angles are congruent, so if I tell you that angle 2 is congruent to angle 6, then you can tell me, hey, the lines are parallel. Yep, it sounds like something you've already heard before, isn't it? If alternate exterior angles, make sure this all makes it to your notes. If alternate exterior angles are congruent. So if I show you that angle 5 is congruent, oh, it's alternate exterior, better correct that. If I look at this and say angle 8 is congruent to angle 1, so if they are congruent, then the lines are going to be parallel. If alternate interior angles are, let's see, here's alternate interior, here's the pair with it. If I tell you they're congruent, then what can you tell me? Then the lines are parallel. Okay. We have to be careful here with our next one. Consecutive interior, we're never going to have them congruent. I mean, just look at angle 4. I'm just going to circle it. And angle 6, those aren't congruent. But if I look at those and I say they are, what's that word again? Supplementary. So I'm like, hey, these are supplementary. Then you can say to me, hey, Mrs. Talley, guess what? The lines are parallel. Okay, make sure that's in your notes. And here we go. Find x and the measure of angle ZYN so that line PQ is parallel to line MN. So in other words, we're just looking at this angle right here and this angle right here, which are alternate exterior. And if I want these lines to be parallel, then those angles are going to have to be congruent. So I would write out, hey, I want 11x minus 25 to equal 7x plus 35. And if I do that, I subtract 7x from both sides. And now I have 4x minus 25 equals 35. I'm going to add 25 to both sides. And if I do that, I get a 60. And if I divide both sides by 4, I get 15. Okay, so I did find x. Now I need to find the measure of the angle ZYN. So here's ZYN, it's this angle right here. I'm going to put my 15 in for x. So I have 7 times 15 plus 35. I got 105 plus 35, which gives me 140 degrees. Seems reasonable. And if this was the case, then these lines would be parallel. Next example. Find x so that line GH is parallel to line RS. Well, if I have this angle right here and this angle right here, and I want the lines to be parallel, then those alternate interior angles are going to have to be congruent. Okay, in order for them to be congruent, I set them equal to each other. And all I have to do on this problem is just find the value of x. So I just solve away. Subtract 7x from both sides. I have 2x minus 21 equals negative 3. Now I'm going to add 21 to both sides. And if I add 21, I get 18. And if I divide both sides by 2, I get x equals 9. Okay, if you want to check your work, which would be a good idea on a quiz or test, here's what you're going to do. You're going to put 9 in there, and you get 81. 81 minus 21 is 60. Okay, I try 9 over here is 63. 9 times 7 is 63. Minus 3 is 60 degrees. They are congruent. Everything is hunky-dory. Moving on to example 3. Just determine if line P is parallel to line Q. I have a feeling we could do, let's figure it out, actually the slope. We could use the points, but if you're given graph paper, let's use the graph paper. So to get from this point to this point, I rise 3, 4, 5, 6, and then I run -4. So I have a 6 over -4, which is -3/2, right, for one slope. By the way, if you went this other direction, just for those of you who are like, why didn't you go from here down to here? I would rise -6 and run +4, which is -3/2 as well. Okay, just so we're clear on that. And let me check. If I go from here to here, I would rise -3 and I run +2. So rise -3, run +2. Yep, they're parallel. And I know a lot of you are thinking, well, I can just tell by looking at them they're parallel. Be careful with that. Be careful, because here, look at this problem. This might be a lead-in, a little too much of a giveaway. There's this dot to this dot. Rise, 1, 2, 3, 4, 5. So I gotta rise at 5. And I gotta run, 1, 2, 3, 4, 5, 6. So my slope is 5/6. And then I look at this one right here, which looks pretty darn parallel. But if I rise 3, and then I'm running 4. So I have a slope of 3/4, while the other one has a slope of 5/6. And these are not parallel lines. So just be a little careful with that, because sometimes they can make them look like they're going to be pretty parallel, just like they did on the lead-in with the optical illusion. So don't be optical illuded on this. Make sure you check your slopes. And we're done. That is a short video.